and we move on with the next presentation also by Jimeno.
All right, thank you very much, Gabriel. So we're gonna shift to another project, and this time it connects the effects of climate change on the energy demand of buildings in the United States. So just quite quickly, the motivation behind is that the United States just consumes a lot of energy in regards to its building stock. It consumes an amount that basically is enough to supply the building stocks of other countries such as Brazil, for example, and India combined, which is pretty much a lot of population served. And we believe that basically what happens to the United States and its building stock matters in terms of climate action, or what is going to happen if we attain targets of CO2 emissions. And what makes it very interesting, the approach of looking at the United States, is that it has multiple climate zones, and that allows us to understand how much the different climate conditions that we could have in different parts of the globe as a first understanding can actually influence whether the energy consumption of buildings goes up or down or remains constant. So that was the question, once again, is understanding if for different locations across the United States, we can understand if climate change will most likely, as one of the scenarios, right, potential scenarios, could increase, decline, or maintain the energy consumption of buildings constant. And this is something that we asked for the last 2 years of research in collaboration also with the Hierarchical University in the UK and TU Munich, also based here in Singapore, and the ETH Zurich. So the methods, quite quickly, just I love 1, 2, 3 steps, very clear. The first one entails gathering a lot of measured data. So we're in the era of big data and digitalization, so why not getting information from open sources? And we were able to gather close to 500,000 buildings worth of information across the United States, across 100 cities, information about forecasts, and also historical values of weather conditions for these locations. And for the first time, we aim to combine the best of data-driven approaches and building physics approaches on all the simulations that we saw in the last presentations. And we tried to combine it in one structure that is called a hierarchical Bayesian model, which is basically a model that helps us to understand different hierarchies in the data, different agrupations, and can combine also multiple sources of information, be it building physics models or the data from these measurements. So we combine all to get a better good prediction forecast, and be able to also not get point estimates of the future or how it's going to look like, but also give us the bandwidth. I think that's very important in climate research, that we understand the extremes and also where is the tunnel, basically how big is that tunnel where we are basically getting into when it regards to climate action. So the third step of this research is taking this model and do forecasting for multiple scenarios of climate change given by the IPCC, and then understanding at the level of different energy services like humidification, cooling, heating, and electricity. What would be the impact of different climate zones and different cities and building stocks in the United States? So moving on to the findings, I think the first one is to understand that depending on how you look at the picture, if you look at 2050, that is the diagram on your left, you will see that there are some areas in which actually the energy demand of buildings can actually go down due to climate change. And it has to do with the reduction of heating and not too much increase in the cooling demand. But also if you look at the the end of the century, you will see more extreme cases. Locations that are on the south east of the United States, which are hot and humid, will become much more hot and humid. Even up to 80% of what is today is very astonishing. And there are some regions that will remain constant, and some of them that will decrease up to 20% the energy consumption because of this shift on the climate. And that's something interesting to consider. I think we saw from the speakers that that cooling definitely will become a very important aspect, but also not only cooling, also dehumidification of air will become very important in terms of energy consumption. So this is at the regional scale. If we zoom in, dive in one of those cities, we see some of these patterns. We observe some of these patterns of the simulations. And this helps us understand a trend where, as expected, heating could decrease by the end of the century in some cities that are in a hot and humid climate, while cooling will go up. But more importantly, dehumidification, the need for dehumidifying air, will be potentially much more important than the other two to be considered. And this brings about a new understanding of what type of technology will need to be implemented in the future. Potentially those hybrid cooling technologies will become more prominent for this type of cities. Giving another example is the idea of shifting of regimes for those who have some knowledge on resilience research, on this idea that we're shifting from predominantly heating regime in buildings to a predominantly cooling and dehumidification regime, where we have to dehumidify buildings much more than before. As we didn't expect it. We thought it was only about cooling, but now it's also about reducing humidity, and that could happen in the future. So to whom does this information impact to? I think first, so we contribute to research in terms of new methods and tools to do forecasting and understanding the uncertainty, the bandwidth of this forecasting a little bit better than before, combining built-in physics approach. So all this theory we have from physics and thermodynamics with also data, which is still a really unknown kind of field, very new, and try to basically have a middle ground. Or thing that we say can provide a lot is, in terms of impact, is that it creates new knowledge for policymakers on the prioritization of energy conservation strategies. And what I mean by that is that as we see that different areas and different cities, different building stocks will be affected the most and first than other cities, then we can basically channel funding in energy conservation strategies at the city level, at the building stock type in the terms of commercial or residential. We did studies for that, so this information brings insights about this. And the last point, I think, is that potentially this type of knowledge can give new insights to the building tech industry in the terms of either reinforcing the idea that we need to dehumidify more buildings in the future, or also reinforcing the idea that we'll have to apply technologies, different technologies for different locations according to how they're going to change in the future. So that's it. Thank you very much for your attention once again.
Thank you very much, Jimeno. To the attendees, please write your questions to the Q&A. I think we only have time for one question to stay in the schedule. And right now, it doesn't seem that there is a question.
If there's no question, I would ask one kind of as a follow-up.
Okay.
And I think it really, what is really interesting about this is the switch from just purely cooling to dehumidification or to humidity as an aspect. First, because from a technology point of view, this is much more challenging. I think one of the remaining gaps for like building technologies is really how to do dehumidification of air more efficient as we do it right now. So that's actually quite a challenge. And I was wondering, Jimeno, have you since then come across studies that investigate this or like on a global scale? I mean, this is the US now, but it would be interesting to look at that on a more global scale.
Yeah, that's a good point. Yeah, I think that would be then the next step. Definitely, I think it's very interesting to look at. I mean, the same way many did with the concept of heating degree days back in the days. Now with this new approach that we call daily enthalpy gradients, which basically account for enthalpy changes rather than only temperature changes. And that helps to understand also how much we will need to dehumidify buildings or also cool them or also maybe humidify in some occasions in really dry environments. So I think that would be a very interesting future step to do it globally, and it's plausible. But so far,
but you since then, I mean, this is already a while ago. Since then, you haven't come across like a larger assessment of that.
Yeah. No, what we published 2020. It was it was very, very fresh. I mean, we did it. It took a long time to do it.
You're right, but the first ideas go back a while. So I was wondering
Yeah.
if anyone else has picked that up.
Yeah, I hope it gets picked up
Okay.
soon. Yeah.
Good. Thanks.
Okay.